Hey guys, Miss Shane here. This is lesson 7. We're going to be talking about scaling and proportions. Since we've already covered or at least touched on both of those subjects, a lot of what we're going to talk about today should look at least a little bit familiar. Our materials for today are going to be a piece of paper, pen or pencil. Your textbook, either the online version or the physical version is fine. And a calculator is optional. You probably won't need it, but you can. Our content objective for today is to be able to solve proportion problems using a tape diagram. And our language objective is to be able to describe how values are related in a proportional relationship. If you're using that physical textbook, please turn it now to page 384. And if you're in the online text, we did move on to chapter 7. So please go to section 7.1.2. Regardless of which method you're using, we're going to be on 7-16, which is talking about Dana training for a bicycle race. All right. Dana is training for a bicycle race. He can ride his bike 25 miles per hour. One day, when he had been riding for 3/5 of an hour, he had to stop to fix a flat tire. How many miles was he able to ride before he stopped? So the information that we were given was that in 1 hour, he can go 25 miles. What we're trying to figure out is how far he was able to go in 3/5 of an hour. So I'm going to set up a tape diagram. We're going to start with just a simple rectangle. On the top, I'm going to talk about time, and on the bottom, I'll talk about distance. Both of these are going to start at 0 because if no time has passed, then he can't have gone any distance, right? And vice versa. If he's going at consistent pace, then if there's been time, then he has to have moved a distance. So our one whole in terms of time is 1 hour, which is equal to 25 miles, because that was the information that we were given. 1 hour is equal to 25 miles. Now I'm trying to figure out how far you can go in 3/5 of a mile. So I'm going to divide my tape diagram into 5 equal sections into fifths so that each one represents 1/5 of an hour. 2 sections would be 2/5, 3 sections would be 3/5, and so on. All right, so now I need to do the same thing on the bottom. I need to split up that 25 evenly into each of the 5 groups. So I'm going to do 25 divided by 5, which is 5, and that tells me that each of these sections represents 5 miles. So after 1/5 of an hour, he's able to go 5 miles. After 2/5, 10 miles, so on and so forth, adding 5 miles for every 1/5 of an hour. So we're trying to figure out how far you could go in 3/5 of an hour. So I'll find 3/5 up on my top and find where that's equal to on the bottom. So it lines up with 15 miles, which tells us that in 3/5 of a mile, or I'm sorry, 3/5 of an hour, Dana was able to ride his bike 15 miles. So we split up 1 hour into 5 equal groups because that was the fraction that we were given. And so then we had to do the same thing to split up our 25 into 5 equal groups to figure out how much they were equal to. All right, so there's our answer for that one. The next problem is related. So Matt thought about problem 716, the one that we just did, and drew the diagram below. Look at Matt's drawing and decide how he is thinking about this problem. All right, so this is kind of tying in to some other stuff that's that we've done before related to proportional relationships. So let's see how this is similar to what we just did to solve 716. So right away I see 25 miles, which is how far he can go in 1 hour. I see 3/5, which represents the portion of an hour that he was able to ride. And that means that my copy, X, this missing dimension, has to represent how many miles he was able to ride before he stopped. That's my unknown piece of information. All right, so this should look super familiar, like something from chapter 4, cough, cough, scale factor. All right, and in this case, our 3/5 is our scale factor. So to figure out our missing dimension for the copy, we're going to do original times scale factor, which is going to equal that copy dimension. So I'm going to take my original dimension of 25, multiply it by my scale factor of 3/5, which will give me my copy. So to multiply a whole number by a fraction, I need to put the whole number over 1, turn it into a fraction. Then I can just multiply straight across. 25 times 3 is 75. 1 times 5 gives me 5. I can simplify 75 divided by 5 into 15, which is the same answer that I came up with before. So either way, they're both representing a proportional relationship. All right, and that's kind of what we're focusing on with these relationships. So in this case, proportions, remember that's when one value changes, it changes the other value in a predictable and consistent pattern. So when one changes, the other changes, right? There's no special buy 3, get $1 off, right? Remember, it's in a predictable and consistent pattern. So in this case, we're comparing the proportional relationship between distance and time. So as Dana rode his bike, because he was going at a consistent speed, as distance rose, so did time, and vice versa. We know that in 1 hour, he's able to go 25 miles, so it makes sense that if he only goes 3/5 of an hour, that he would go 3/5 the distance, in other words, 15 miles. All right, so we have been practicing finding the fraction of a whole. We said our whole was 1 hour, which was equal to 25 miles, right? Remember our tape diagram. But then we had to find 3/5 of 1 hour, or 3/5 of 25 miles. So that is finding the fraction of a whole. Now we're going to practice finding the percent of a whole. Okay, so I know that 1 whole is 1 hour, which is equal to 25 miles. He still went 15 miles, but I want to figure out what percentage of an hour he was able to go. My information I was given is in a fraction though, so I need to convert that to a percentage. And remember, a percentage is just a fraction out of 100, or a fraction with 100 in the denominator. So I'm going to set up 3/5 to find an equivalent fraction with 100 in the denominator. To get from 5 to 100, I'm going to multiply by 20. I have to do the same thing on top, so I'll multiply 3 times 20, which will give me 60, which becomes the numerator of my fraction out of 100. So I know that in order to go 15 miles, Dana has to be riding his bike for 60% of 1 hour. All right, we went from fraction to, well, actually, we went from fraction to fraction of a whole. Now we went to percent. So now let's figure out what this percent of a whole actually is, right? Let's figure out what 60% of 1 hour actually is. So I'm going to set up my tape diagram. I'm going to talk about percent this time on the top and time on the bottom, because I'm trying to figure out what 60% of 1 hour is. They're both going to start at 0 again, and 100% is obviously 1 whole, and in this case 1 hour would be 100% of the time, right? 100% of an hour is 1 whole. All right, and we figured out on the last screen that 3/5 is equal to 60%. So I'm going to divide my tape diagram up into fifths. And I know that 3/5 is 60%. To get from 60 to 100, I know I need 40%. And I have 2/5. These are both equal sections, so I'm going to divide that 40 up into 2 sections. So I know that each one is representing 20%. So if I'm at 60 here and I add one more section of 20, I am now at 80%. And because these are all equal sections, that means that all 3 of these have 20% in them as well. All right, so we've broken up our percentages into 5 equal parts, but now we need to figure out how much of an hour is equal to 60%, right? So we know that 1 hour is 60 minutes. So I'm going to divide the 60 minutes up into all 5 of those sections. So 60 divided by 5 gives me 12, which means that there's 12 minutes in each fifth of an hour, right? So now I can look at my tape diagram. I'm trying to find 60% of 1 hour. I will line up 60 and find that it is 36. So now we can put all of that information together to say that Dana rode his bike 15 miles in 36 minutes before getting a flat tire. All right, so that kind of information that can be really helpful in life, right? Like that'll totally apply once you're out of school, but it's also going to apply for your lesson 7 assignment. So you're going to be working on problem 7-21, which is about Amina's boat Amina's boat that travels 35 miles per hour. So right away I'm looking at this, and that sounds like Dana, who can ride his bike 25 miles per hour. So Amina's boat travels 35 miles per hour. The best fishing spot in the lake is 27 miles away from her starting point. If she drives her boat for 2/3 of an hour, will she make it to the best fishing spot on the lake? All right, so we are setting up a tape diagram here where we're having time on top, distance on the bottom. We'd have 1 hour as our whole for time, but 35 miles as one whole for distance. Remember with Dana, we had it as 25 because in 1 hour, Dana could ride his bike 25 miles. In this case, Amina's boat can go 35 miles in 1 hour. All right, so A says we're trying to figure out 2/3 though. So I'm going to divide my tape diagram into 2 equal sections so that each one represents 1/3. So I have 2/3 of an hour, and I'm trying to figure out the distance represented by 2/3. All right, that's your hint for part A. For part B, you're going to have to go backwards, and you're going to have to figure out how long it will take her to go 27 miles. So my hint for you here is to figure out the distance between 35 and 27 and try and break that up into some parts that you can make sense of. All right. Oops. Answer in both a portion of an hour and in minutes, okay? The other problem that you are going to do, pretend like that 27 miles isn't there anymore. So what you guys are going to do next is 7-24, where you're going to use the given information to fill in all of the missing labels. So I see 100% is my whole, right? Pretend like this is a tape diagram. It looks very similar. And I see 60 here. So 60 plus something has to equal 100%, right? One whole is always 100%. Obviously, that something is 40, so that tells me that this section right here is 40%. So 40% is equal to 28 students. I need to figure out how many students 60% is equal to. So my hint for you guys is to divide that 28 students into 2 sections that are both 20%. So if they're both 20%, how many students are in each? Right? It's the same section as 40%, and I divided 40% into 2 sections, so I'd have to do the same thing with 28. Then you can probably do something similar over here to fill in the missing labels. All right, so these are the 2 problems that I'm going to have you do for this lesson. There is it's posted on Google Classroom, the assignment, so just complete that there. Let me know if you have any questions. I know this one was kind of a lot. All right, have a good day, guys.